Okay, right, hello and welcome back to another course. So in this series we're going to be having a look at Niagara, which is the Unreal 5 particle editor system. Don't worry if you've never touched Niagara before. We're going to start right at the basics with introductions to the UI, talking about what particles are, how systems work, all of that kind of stuff. If you have a little bit of knowledge about materials, some data types, things like floats, vectors, all that kind of stuff, that's definitely going to help. I would recommend doing my materials course first. I think it covers a lot of the concepts that will get applied to Niagara, but it's not actually a prerequisite. So if you've got some experience, that's fine as well. But this is going to be a little bit more of an advanced class. Niagara is a really complicated, powerful tool. And so if you are brand new to the engine, you maybe want to do some sort of base learning about sort of the whole engine as a whole first before you jump into particles. With that said, we're going to cover, as I say, right from the very basics, the UI, terminology, all of those things, do a few worked examples, have a look at some theory, so actually break down almost every module in Niagara, categorized and how they work and what they do. We're going to talk about some of the more advanced concepts. So although this is called Intro to Niagara, there's actually some more advanced things in here as well. So collisions, events, attribute reader, that kind of thing. And then we'll end up with some worked examples as well. So the really complex things, grid 2D, simulation stages, all those kinds of really advanced Niagara things, they're going to come in a later course, but they will be coming. So this is sort of like an entry level, but there's still some quite advanced things in here as well. So lots of content, lots to get through, hopefully going to be enjoyable, and we'll make some cool particle effects along the way. As always, if you have any questions or comments, please don't hesitate to get in touch. I'm happy to help people either on Discord or email, however that is. And yeah, and let's get started in the next video with some basics of Niagara, with some terminology and kind of what actually is a particle system and how do we use one. So we'll see you in the next video. Okay, right, so before we actually get started with anything in the engine, I want to go over some terminology, and I've created a glossary page. If you have the preview version, this won't be there, but if you're watching this video, that means I've updated it, so go and check the source files. There'll be a few minor tweaks, including this this texture or image, and so yeah, go and get that. If you're missing that, that's why it wasn't in the preview version, but it's here now. So so yes, before we actually get started with opening up Niagara and editing things and looking at how it all works, I want to go over a little bit of terminology. So there are three types of or three places we can have information in a particle system. There is the system, there is the emitter, and there is the particle. And all of these areas, all of these kind of groups, are just places where we can do calculations, we can store data, we can read data, and that's really what a particle system is. It's a data management tool. If we think about a particle, it carries the data with it of what it's doing, and so one of the most obvious ones would be position. Where is it? Where is it in the world? What color is it? Is it red? Is it green? Is it blue? Does it have textures? Is it a mesh? Is it a sprite? Is it a light source? Whatever it is, where is it going? What velocity it has? All of this sort of data all comes down to the particle. So the particle contains all of that data, and then the emitter is a way of spawning and controlling a group of particles. And so here we have our emitter stages. Now anything we do in the emitter stage can be read by the particle, and so when we spawn, we'll spawn in a volume that will be done during the emitter stage, and then the particle will sort of choose where it is, and then carry on and sort of with the simulation from that. And so then taking that logic one step further, we have systems. So in this example here, a system could be something like a campfire. It's an actor, it can be placed in the world, and it contains all the data in it as a system that can be then carried through to the emitters, carried through to the particles. And so we have a type of asset in Unreal called systems that we'll be making, and that's what we can put in the world, and that's what we can kind of edit data on and things like that. Emitters, another type of asset we create, they are kind of the next level down. So in my campfire example, if you had one emitter for the flames, one emitter for the embers, one emitter for the logs, etc. They're all individual kind of components to that particle system. These can't just live in the world on their own. You can't just put a texture in the world. You need a plane to put it on, or you need a model to put it on. In the same way, you can't just put a emitter in the world. You need to have a system for it to live inside. And so there is this kind of like breakdown between these. It's very easy to understand textures, materials, and meshes. They're all separate things. Here, emitters and systems are very similar things, but you have the same kind of idea that you can't put an emitter in the world. It needs to live inside a system. You can't put a texture in the world. It needs to live on a mesh, or at least live in a material, and a material needs to live on a mesh. And so everything kind of has its own sort of role and place within the hierarchy. And we'll have a look at this, and we'll cover all of this in more depth when we actually look at examples. But I just wanted to get this idea and this terminology out first. So we have system. That's the actor, lives in the world. It contains everything. We have emitters. They're the actual particle parts. They contain information about how many, where, how fast, all of those kinds of things. And then the actual individual particles themselves. And so that contains all the information about that individual particle, as opposed to sort of the emitter, where it's the particles in general. Now within that sort of dichotomy, or that trichotomy, I guess, because there's three, there is another set of two things, spawn and update. And we can see here system spawn, system update, emitter spawn, emitter update, and then particle spawn, particle update. So spawn modules run once, just when we spawn them. So it's kind of like a bit like a creation script. If you've done some blueprint work, it's a way of setting up initial values and also doing randomization. And then update scripts or update modules, they run every frame. So anything we need to change, such as scaling over time, changing color, physics, collisions, forces, all of that kind of stuff, that's done on update, and that's every frame. So which module lives in which area? It does make a difference. It is important to put things in the right places, and we'll cover that when we go over the different modules. But I also wanted to get that kind of idea between these three things in place first. So we've got systems, whole thing, emitters, individual parts, and then particle is like per particle, and then spawn is a one-time at the start, and update is every frame. And we'll see all that as we start building up and developing our systems. Hopefully that makes sense. Again, we will cover this in more depth as and when they come up, but I just wanted to sort of like lay that groundwork before we even get into to opening Unreal or opening a system and having a look at everything in there. So cool. With that done, I think the next thing we're going to talk about is data types, which again is going to be a separate thing that's new for wasn't in the preview, but yeah, we'll cover that in the next video. Okay, data types. So again, I have a system here called 06 data types. You won't have this if you're on preview, but update and get the latest source files and you will. And what we have here is just a very simple example of the different data types that we might be working with. Now, as I say, if you have done some material work, you'll understand hopefully scalars and vectors as different parameters. Now, scalars in materials are basically the same as floats. And so here we have a float, which is a floating point value. So a decimal, we can have positive and negative, we can have all the accuracy that we want. And that's going to be one of the most common types of data that we're going to be using. Now, it's really important to always make sure that we're using the right data type. Niagara won't accept the wrong data type, and sometimes when we're working, we think we're trying to do one thing and it's actually in a different data type. It's very important to make sure we get that correct. So again, we'll cover that as and when it comes up in our systems. But I just wanted to do a sort of a quick example here, or a quick breakdown to again lay that foundation, that groundwork. So that's floats, that's floating point value. We will have used linear colors if you're dealing with materials. Now, often in materials, we'll call this a vector. So v-click is the vector parameter, but actually it's a vector 4 and it's a linear color because it's RGB and A. Now in material land, that's kind of fine. We sort of gloss over the difference between a vector 3 and a vector 4, but here in Niagara it's much more exact, and so you have to make sure that you're using the right thing. And we'll see where that comes up as well. So for example, if we're doing something like a wind direction and we're sharing our wind direction through a parameter collection between materials and Niagara, Niagara is expecting a vector, materials are expecting a linear color, and so there's some conversion that needs to be done, but all that conversion can be done. So but it just can be a bit confusing if you're looking for something that isn't there and it's because your data type might not be correct. Okay, hopefully that makes sense. We have booleans on and off, same as materials. We'll use those occasionally. We have integers. Integers don't exist in materials. They are not something that GPUs coded to understand, but we can use them here. So that is a whole number. Anytime we're dealing with something that only exists in single values, so for example, spawn rate, how many particles, well, you can't spawn half a particle, doesn't make any sense, and so that's where we might use integers. And again, making sure that the correct data type is being used, otherwise you might run into issues. Vectors, as I said before, linear color and vector, they are very similar. If I do 1, 0, 0, if I do 1, 0, 0, this is the color red, but it has this alpha channel. And so when we're dealing with colors, we have an extra channel. When we're dealing with just vectors, we have only the 3 channels. And this can be direction, could be used as a color. So sometimes you have that interchangeability. Position is a very common vector, but actually, as of recent updates with Niagara, positions are now their own data type. So since Unreal's moved to this large world, you can store your positions as position data, a specific position data type that has a little bit more accuracy. So with floating point values, or with any kind of data, there's only as much precision as you give it information for, or as sort of you assign to it. And so there was problems with very large positions causing problems when using vectors, and so position data type is sort of there to fix that. So it's the same thing, it's 3 channels. If I make this into a new value, you'll see it looks exactly the same as a vector, it's just 3 channels, but the way it's stored has a bit more precision, so it can deal with very, very high numbers. And again, we'll look at conversions between those, and we'll see when that comes up in our examples. Last one in here is vector 2D. This is UVs. Hopefully you'll know these from materials, but yeah, we'll use them when they're there. This isn't an exhaustive list. There are many, many types. If I do a new, make new common, so these are the common ones, these are all specific ones. Again, we'll go over this in more detail later on, but I really just wanted to highlight some of the data types that we're dealing with, making sure that we understand what a int is, for example, what a float is, for example. So yeah, that's all here. We can see, if I go over to this side, and we'll cover this again in a bit more, there is some color coding to this. So one of the things that Material Editor is a little bit lacking is it doesn't color code its parameters. If you're dealing with particle systems or you've done some blueprint work, you'll notice that there is color coding, which helps if you're into colors. So you can use this down here, or this sort of color coding. So floats are this color, booleans this color, linear color, position, etc. Yeah. I personally am colorblind, don't rely on colors very much, so I don't pay any attention to this, but it's there, so you can use it if you wish. And we'll cover again this part of the UI, etc. in a bit. So key takeaway here is just those data types. Make sure that you understand what kind of data you're working with. As I said in the previous video, particle systems are just data management tools. That's the data, or like all of this data is this thing we're going to edit, and we're going to control things like positions and velocities and that kind of thing. But it's all just data at the end of the day. But sometimes it's very easy to get into problems because you're trying to use one kind of data, or you're expecting something and it's not quite what you want, and that happens very commonly. Floats and ints, and linear color, position and vector. Those 3, you think it's one thing and actually it's stored as something else. So just a bit of a thing to watch out for if you are kind of struggling to do a thing. Cool. All right. Let's have a look at the actual Niagara UI, and we'll do that in the next video. Okay, so here is the actual start of the preview course. This is the introduction to Niagara systems, Niagara UI. Hopefully that has scaled correctly for you, but if we sort of zoom around this sort of set of comments that I've made, we can see how the UI is. So first thing up here, top left, is the viewport. You can click and move the mouse. You can rotate around, all the usual kind of settings. We can't see anything in here because we don't have any particles being spawned yet, but when we do, we have a viewport up here. Word of warning, the viewport in Niagara isn't very good. There are lots of things that can cause problems. We'll talk about them when they come up, but it is only a preview, same as in materials. It's only a preview. It's not designed to necessarily represent everything that you will see in the final. And so because of that, it's always good if you've got two monitors to make sure you've got a second window open, and we'll jump back and forth between looking at things in the world and looking at things in the preview when we need to. But just be aware, there are a couple of things that the preview doesn't do very well. So yeah, well, we'll come across those when they happen. As always with any preview scene, there is a preview scene settings window opened over here. We can set things like post-processing, we can turn off the skylight, we can change the environment if we want to have that. Sometimes it's nice to work with just a black background. That's the old Cascade way. But whatever you want to do, you can change the cube map if you wanted to make a cube map for your level that better represented the lighting in your scene rather than using Epic's offices, which is what this is. But that can all be changed there, and that's common to anything in any of the preview windows in Unreal. Okay, let's come back to this one here. Let's start with here. So we're in a system. As I said before, there are systems and there are emitters. What this big word here is in the bottom right corner tells you the context that you're in, and that's one way of looking. Also, emitters cannot have multiple emitters inside them. When we open an emitter, it will only ever have one stack, and in fact, if I just do that, and we'll do that here. So this is the Niagara emitter example. In this level, we can see here we are in an emitter context. Oops. And we only have the one sort of module stack, and that's this one here, Niagara emitter. Also, the system properties don't exist in an emitter. They only exist in the system, and that's this bit here, system properties, which again is color coded. So this is our parameters and our data that's to do with the system, and we'll cover that in a bit more detail when we make things. Then we have our emitter, or as many emitters as we need, that we can add to our system. Now, talking about emitters, there are effectively two types of emitter. This emitter here, this only exists inside this system. We can see that by this little icon in the top right corner. So this says open and focus parent emitter. So if I were to do that, I already have it open, and then I press Control B. That is a shortcut for finding content browser that works throughout Unreal. That finds this as an asset. So this emitter has been saved as its own asset, and that's really powerful. So we can make changes here, and if we just say, let's add some gravity, and let's do that in particle update gravity. Don't worry too much about this. We'll be doing this later on. So if I add some gravity, I get a warning. We'll ignore that. If I come back to my system here, nothing's changed, nothing's happened. But if I go back here and click apply, now my system, that gravity force has been applied. So there is a series of inheritance. If you've done materials and material instances, it works very similar. Any changes you make to the material have to be applied before they become visible in the instance. Here, same thing. Any changes we make in the emitter have to be applied before they'll be visible in the system. And what's nice about this is we can make things that are reusable. We can make kind of base templates. if we're dealing with something like fire, it's a very common particle system or particle effect to have in a video game. You might make a base embers emitter and then override values per system to kind of give you different types of looks. So whether it's a big campfire or a small fire, torch, something like that, you can change the settings in the system and override from the parent that you've inherited from. Hopefully that makes sense. Just delete that because we don't need that. Click apply, and now the changes are back here. So as I said, this emitter here only exists inside this system. If we want to create emitters like this, we can just do add emitter. That will add from the content browser, or we can just add an empty emitter, and then we can kind of create our own from scratch. But these will not exist on the disk, and these cannot be shared between different systems because it only exists here. If we do want to save it out, we can right click, create asset from this, and then we can save this out as its own emitter for use elsewhere. So there's a lot of flexibility in how we work. How we doing time? Okay, cool. These two, as I say, are the same. This one's name has been overridden. Do be careful. If you do change the name of something, it doesn't show you any update that that's been overwritten in any way. If I rename, if I delete the name, it won't let me. I should reset back to this, but there we are. So if we want to rename an emitter, just F2, and now there's no visual link that these are the same thing anymore, but it can be useful if you want to organize things and name things, but just be aware that overriding the name does sort of obfuscate a little bit. Instead, we can just click and create these comment bubbles. So if I just create a new emitter here, if we click on this, we get the little comment bubble, and we can rename it up here. So that would be my preferred workflow rather than renaming, but up to you. Cool. Okay, so viewport, system emitter, inherited emitters versus system only emitters. A few other things we have down here on the left are parameters. If I were to select this emitter, it changes what is highlighted here, or what data is here. So this is context sensitive, same as the details panel would be. If I deselect, we're always going to have the system attributes. Now the system data is here. Things we might want: system age, how long has this system been alive for? That's information we could build our effects off. Current loop duration, loop count, looped age, normalized looped age. All this data exists in the system, and that can be used here at the system level, can be used here at the emitter level, can be used here at the particle level. If we select this emitter here, obviously that's going to give us also emitter properties, so emitter attributes. How long has the emitter been alive? So we have here two parameters, both called age, but the system one is called system.age, and the emitter one is emitter.age. And so we have different what's called namespaces where we can store our data. So anything stored in system uses the system namespace, anything stored in emitter use the emitter namespace, and then particles as well. So we have particles age as well. So some parameters make sense to use the same name again and again, but there's different things that they're referring back to. So how long has the system been alive? How long has the emitter been alive within the system? How long has the particle been alive within the emitter? And again, we'll cover these when we need them. I'm not going to go through every single particle in the system here. Cool. So that's our parameters. This is all the data that exists. We have the ability to have our own data, user parameters, and we'll cover that in the next video because there's quite a lot to user parameters. So we'll keep that out for the next one. But the last thing we want to cover in the UI here are these four down here. So we have a timeline. So we can see how our different emitters within our timeline, and this is just set on a 10-second loop. And so we've got this final break here. We can bring this forwards. Even if our system is set to not loop, it's set to just kind of carry on and repeat, the 10-second loop will loop it in the preview. And And so just be aware that the preview window here isn't the same as what you'll see in the world. So if you make something that doesn't ever reset, it will appear to reset while we're working here because it's hitting that 10-second loop in the preview. So just as something to be aware of. We have a few options. This little man or little person icon, not sure why that's isolate, but it is. This allows us to just view a single thing at once. So we can see here these get grayed out, and now we get just the visibility of this one. We can also enable and disable with the check marks, and they're repeated down here as well. We can select the renderer, and we'll see when we use renderers, you can get multiple renderers and they'll all appear down here as well. I think now you can isolate multiples at once. Yes, you can. So you can group select and then isolate, which is nice. That's relatively new as a feature. But yeah, we can temporarily turn things on and off. We can change loops. We can adjust things on the timeline, and we'll use this a little when we're making our effects. Next we have curves. If I make something that has a curve, and let's just do scale, color, and curve. Again, don't worry too much about what I'm doing here. We'll be doing this later on. But we can control any of our parameters with curves, and we'll go over that. But what we can also do with that is export them to the curve window. So here, if I click import, click export, the little alt arrow, you can see how we can kind of move this to here. And we'll do this with different data at the same time, and it allows us to sort of see multiple curves at once and edit things together. I don't use this a lot, I'll be honest, but we'll cover it a couple of times. And this is a fully featured curve system, so we can do tangents and we can do snapping and various things, and we'll cover that. Finally, we have our log and some statistics. Now the log will give us any errors if we have errors. If I just add that gravity again, should give me an error, and then say yeah, so it can't compile, and there's errors up here that it knows how to fix, and we'll fix those. Cool. So that's the main parts of the UI. I think that's enough for now. Viewport up here, with caveat that it's not perfect. System properties, emitter properties, timeline, curves, and parameters, and we'll cover user parameters at a later date. Cool. Okay, right, so if you've been following along and watching all these videos, you are probably thoroughly confused right now. There is a lot going on with Niagara, a lot of terminology, things like system, particle, emitter, that have very specific meanings, and it's a lot of information. If you've got some background in, say, computer science or environment art, something like that, maybe a few of these terms are familiar. But if you're brand new to this, there's a lot, and I fully appreciate that. It is a very powerful, very complicated system, and it is designed to do things that are really, really complex, really, really powerful, really cool, way more than we probably need to do 90% of the time. And so because of that, it has this real steep learning curve, a lot of very complicated and powerful things you could do that are available to you, but actually 90% of the time you want to do something simple and easy. You don't need to use all this complicated stuff. So hopefully it isn't too intimidating. But what we're going to do in this video is we're actually going to make something. We're not going to worry too much about kind of exactly what we're doing, but we're going to start with one of the templates that the engine gives us. So Epic have kindly given us a bunch of placeholder or sort of starting points to work from for our particle systems, and we're just going to go in and just in the level here, if I hit 2 on the keyboard, we're going to start with this one, hanging particulates. Very fancy way of saying little things in the air, and we're just going to go through and make this system. We're going to start with the example, and we're just going to side by side have a look at what there is in the engine, what that's provided, and we're just going to replicate it just to get ourselves into this workflow, to get a handle on what Unreal's doing, handle on how Niagara works, look at some of those UI tools that we looked at before, and so on. And so really kind of take a step back from the theory and do some simple worked examples, and then we'll have a big deep dive into the really complicated theory and do some more complicated worked examples at the end. So hopefully that kind of makes sense. So if you are feeling a little bit lost, feeling a little bit overwhelmed by all the things that I've explained so far, hopefully I've explained them in a way that makes sense, but it's totally understandable. It's exactly how I would be if someone tried to explain all this information at me, just as a wall information. And so what we're going to do, is some really simple worked examples, and kind of like just get a bit more used to what's happening in Niagara. Okay, so in which case I'm going to go into the introduction folder here, and I'm going to create a new Niagara system. So just right click, Niagara system, and it gives us a few options. So a new system from selected emitters, so we can select emitters in our project and start with them. A new system from a template or behavior example, so same kind of thing. Copy an existing system, so just duplicate something you already have, or create an empty system with no information in whatsoever. Well, that's not what we want. I'm going to do new system from selected emitters, and if I go into the templates tab here, there are the engine provided ones, and the one I want is this one, hanging particulates. Again, very fancy way of saying little dust motes, or maybe leaves or bits of paper or something like that, confetti, anything that's kind of like floating about in the air. If we double click this, it will add it to our emitters to add section, so we could add multiple emitters here if we wanted. The green arrow will do the same. I don't want to have two of them though, so I'm going to delete that, and we're just going to finish. We're just going to add one copy of hanging particulates to our system. I'm going to give this the class underscore sort of prefix for demonstrating it's the one from the video, and this is going to be the same as this. So if we open this up, what do we have? Well, we have a cloud of little white dots. Hopefully that's visible with the background here. Again, if you want to get rid of the background or change it, we can change the preview scene settings, but that is what we want. That's our starting point. And we're going to go through, and what I'm going to do is I'm going to create an empty emitter. So if I right click here at the background, create an empty emitter, this is going to give me nothing at all, and I'm going to slowly go through bit by bit on this side and add that across to this one to build up this system and build up this this effect. And hopefully in doing so we'll understand a bit about what these modules do, and the workflow, and how it all kind of comes together to create this effect. Okay, so start at the top, properties, and don't worry, we're not going to do too much in depth here. Again, we're going to go through each of these modules later, so I'm just kind of making sure that the settings are the same. So here, CPU sim dynamic, and this is set to CPU sim dynamic. This is all fine. Emitter summary, nothing in here. Emitter spawn, nothing in here. Emitter update, we want to have an emitter state, so emitter update. So the way we add modules is just with these little plus icon. So this is our group, and you can see we've got our spawn and update groups for both emitter and for particle. We covered that in the terminology earlier. And the way we add a module is just to click this little plus icon, and this will give us this huge window. There are hundreds and hundreds and hundreds of modules. This is context sensitive, so if I'm adding here in the emitter update section, I'll get a different list as if I was adding an emitter spawn or particle update. So if I do emitter update, this is not an exhaustive list of everything. There are many others, and hopefully it gives us a few commonly used ones here at the top in the suggested bit. So generally you want to look in here first, and then add something, but we can also just type in, so like any of the Unreal search bars. So we want an emitter state in emitter update, emitter state, there we are. Just to sort of demonstrate, emitter state only is allowed to exist in the emitter update section, so it wouldn't exist here in the emitter spawn section. And if I try and copy it, drag and drop it across, it will say cannot be moved. This is not a valid for this usage context. So that's just saying this module here affects the data that we're doing an emitter update. It can't be used with emitter spawn. So if you can't find it in the list, make sure you haven't accidentally clicked on the plus here instead of the plus here. Okay, so this is set to self infinite 2, and we'll just copy those settings across. Self infinite 2. So this is telling the system how to loop, how to kind of what to do when it reaches the end of its lifetime. Should it be repeating, this kind of thing, and we'll copy this across. And as I say, we'll go into these into more data, more depth later on. Okay, spawn rate. First thing we want to kind of do with a particle system is have some particles. Spawn rate here is 50, and we'll just copy that across as well. Create 50 particles. And I might just quickly drop to the end here because I want to see these as they start, but currently we have no renderer. So there's no way of drawing our particles, or rather our particles aren't being drawn to the screen because they don't know how to, they don't know what they should do. And we're going to just add a sprite renderer to copy this this existing one here. And we'll probably leave all the settings default. I don't think there's anything actually in here that we need. So, but now we see some particles. We see the big white ball at the center of our system. And if we look closely, that repeating, so the 10-second mark, the timeline resets and the ball is going to sort of stop glowing as much. And we get that starting building up again from scratch. So this is that 10-second loop I mentioned before. If I have a look in the world, if I just replace this one with my class one, that 10-second loop will never happen. So the emitter state is telling it to just carry on forever, but the preview window in Niagara is resetting every 10 seconds, and so there's a sort of a visual mismatch, which once you understand that's what's happening, it's generally not a problem, you can just work with it. But if you're looking at that loop resetting and wondering why it's happening, well, in the world it's not actually happening, it's only happening in the preview. So definitely something to be aware of. This is lying to you. This doesn't really happen. That reset is just a reset. If you do want to reset, spacebar will reset your system. It's a very handy shortcut. In the world, if you've got an emitter selected, then the slash key, one of the slash keys, that one, the one with the question mark, will reset selected. And shift slash will reset everything, and personally I reset that to spacebar. So you, in the editor preferences, you can go into keyboard shortcuts and reset that. So I like to have it consistent between Niagara and the world, but your mileage may vary. You can do what you like with that. Anyway, back to our hanging particulates here. So we've told our system to loop. We've created some particles. Now we can't really see that there are lots of particles here. We can see there's lots of particles around. That's this one, and we can use our isolate or our disable to see that. But I want to know how many particles are here, and so actually up here in the show menu, it's quite nice to have particle counts enabled. Just a little bit of information in the HUD. It gives you how many currently and how many maximum. But it shows me there is a certain number. So my empty, this one says empty, that's the name. I might just give it a new name, and I'm going to call it my hanging particulates, just to make sure that I know this is my one. And now that's telling me that I have particles here. So it's always a good idea to have this on. If I disable my render a second, you can see even though we're not seeing anything at all, we're not rendering these particles, they still exist, they're still being calculated. So it's very easy to get into a state where you don't see anything. Now you don't see anything because your particles are either not there, or they're too small, or they're invisible, or they're off screen, or all sorts of things could happen that meant you couldn't see your particles. But if you've got the count there, it's a good idea, because you can always see, well, okay, actually I've got 400 particles. Well, where are they? Well, in this case they're not rendering because of a lack of sprite renderer. Okay, that seems like a good place to stop for this video, just to kind of break this up and break this down. What have we done? Well, we've created a new emitter, an empty, right click, add empty, and we've added a couple of modules. So we've got a module controlling the emitter state. How does it loop? What does it do at the end of its lifetime? Well, in this case, I just want to keep looping. A spawn rate module. How many particles are we spawning? And then what are we spawning? Well, we're rendering sprites on our particles, and that's just this white circular texture, or white circular material, I think. But yeah, cool. Okay. In the next video, we'll go down and we'll add some more of these modules and try and recreate this effect as fully as possible. Okay, right. So have some particles, have quite a lot of particles, that's fine, but they're all on top of each other. It's not very interesting. What should we do about that? Well, if we look at the particle spawn section, there are two modules in here, one initialize particle and one shape location. So let's add those to our version. Initialize particle and shape location. Now again, we will cover all of these in depth in the actual module breakdown, but quickly, initialize particle gives us a quick way of controlling a lot of the sort of starting attributes of our particle. First one up here is lifetime. Now this is set here by default to direct set. That means we're just going to set the lifetime of all the particles to 1. That's fine. Well, they spawn and then eventually they die. But that's not very random, not very interesting. And we're just going to copy this through. And so we're going to do a random between 5 and 8 seconds. And so I can change this drop down to random and then change this to 5 and 8 seconds. Now this has been hard coded in, and there's other ways to create randomness, and we'll see that later on. Now, as a quick aside, whenever we're making particles, we're trying to generally replicate natural phenomena, dust, weather, fire, wind, whatever it is, that has a lot of randomness to it. So anywhere we can add a bit of randomization, it's generally a good idea to do so. And so even if this was like 7 and 8, like very similar numbers or quite close together numbers, it would still get a little bit of randomness to it. And so you want to kind of go through and randomize as much as possible, in my experience anyway. Cool. Color of our particles, that's just set to white. That's fine, we can keep that the same. Mass, we're not really using mass. You can set mass on particles and then try and do sort of physicsy calculations with them, and we'll cover that later on. But where we have got some set here is a sprite size mode, random uniform. So go back to our initialize, sprite size mode, and there's 4 options: uniform, random uniform, non-uniform, and random non-uniform. Now, terminology wise, these are very wordy, they have technical meanings, but they're not the easiest to understand, but we'll just have a go through and see what it does. It's uniform sprite size. So what does that mean? Well, our sprites, remember we're using a sprite renderer here. If we change this to a wireframe view, our sprites are little quads, are little planes. They are a square mesh, 4 verts, 2 triangles. I'll zoom in a little bit, you can maybe see that a bit better. And they are squares, so they are uniform. So the size X and the size Y is the same. And that's what this uniform stands for here. That's what that uniform means. If I make this number smaller, that wasn't smaller, that was bigger. If I make this number smaller, then my sprites get smaller. If I make my number bigger, they get bigger, and so on and so forth. Now this is in Unreal units. So a size of 1 is 1 centimeter. So size of 5 would be 5 centimeters. That-ish size, which is pretty big for dust boats and things hanging in the air. But generally, I work under the principle, if it looks right, it is right. If we make these real size, we're not really going to see them, and so we might control these, have them bigger, and then control the visibility of them other ways, and what have you. But yeah, the important thing here is that these are in Unreal units. Uniform meaning keep them square. So if uniform is square, non-uniform allows us to do long and thin, and we can make sort of rectangles. So here it's 10 units by 50 units, and we can see that happening here as these spawn in. And then the random ones allow us to randomize between two sets of values. And so the same as up here. So if I do random uniform, well, either be a square that's size 5 or a square that's size 10, or any random value between that. So it's a min and a max, and it does say min and max here, but it's always going to stay square. It doesn't matter how big, how small, it's always going to be the same. And then random non-uniform, you can probably work it out. We can now have a min and a max, and these are what's the word, independent. So it will randomize the x size and randomize the y size, and you can see that here. So we've got some tall and thin, some short and fat, all the different sizes and shapes being spawned in. So depending on what we're making, we'll have different settings for our sprite size. In this case though, we're just copying what's here, random uniform to 3.5, random uniform to 3.5. And now our size is about the same. Well, our size is exactly the same because we've copied the numbers exactly. Okay, sprite rotation, you might have noticed, if I just make these bigger again, you'll notice that they're always square. They're always sort of square to the camera, I guess I should say. If we want to add some randomization, we can create a random rotation. And now they will be randomly rotated. Now in actual fact, if I go back to my lit mode, this is a circular material. You can't tell whether it's rotated or not, but it's good practice to have it on in case someone affects your system later and puts some textual detail there. We don't want it to be repetitive and square, and we want to see randomness to it. So it's always a good idea to just check your wireframe, make sure that things are rotating if you are using a placeholder texture for this. Cool. Let's put this back to 3.5. And there are other options for rotation mode. So you can set your rotation by degrees, you can set by angle in the 0 to 1, so kind of percentage rotation, and we'll cover those later as well. Similarly, how we can't see any rotation because it's using a circular material, we can't see any UV flipping either, but it is set to random X and Y. And what this does, we'll take our texture and just kind of flip it. So if you had random in X, random in Y, gives us a little bit more random reuse where it doesn't really matter whether it's rotated in X and Y or not. And we'll see where we use that as well. Okay, this is a sprite. We can see we've got a sprite renderer here. So we aren't going to use the mesh attributes and we aren't going to use the ribbon attributes. We'll cover those later when we do use those things. And that's the end of this module. So we'll just close those down. Okay, quick recap. Randomizing values, we want to random where we can. Random, 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 random. We haven't randomized the color. We could do that. If I set in here a random range color, I could say go between red and blue. And now we have red ones and blue ones and purpley ones, and all the colors in between. And so we could randomize that. But for this stage, I'm just going to leave them as white. And yeah, we can randomize the colors, randomize the size, randomize the rotation, and randomize UV flipping as well. So as much randomness as possible in our initial spawn. One point of UI, we have up the top here some section headers, and so you can kind of break down exactly which section you're looking at, or you can just leave it on all and have all the data. So it's quite nice if you're dealing with something really complicated, just to kind of bring that down. And it tells you a little bit about what's happening as well. So the point attributes here, these are common to all of your particles. It doesn't matter whether it's a mesh or a sprite or a ribbon or whatever, it's going to have a lifetime. Whereas these ones are categorized by the renderer type that they're referring back to. So a sprite renderer will refer to the sprite settings here in initialize. Okay. All well and good so far. Next thing we want to have a look at is this shape location. So we are here, it says box plane, here it says sphere. So this is a little UI hint for us. It tells us where, if you click on it, it will tell you where that setting is. And so it used to be we had different modules. So if you're on an older version of Unreal, you might find there's a box location and a sphere location and a torus location and what have you. Here now in the latest version, they've put all of that in a single module. It's called shape location, and you select which shape you want. Simple enough. We'll go through all of these at a later date, but for now we'll just copy the data across. So a box, here it is 400, 400, 256. That's how big the size of our box is. So box size 400, 400, 256, and the midpoint is at a random range vector. Okay, so this is our first dynamic input. So if I look at this module, which is the new one, box midpoint is just an input. It's just a single vector input. Doesn't give me any option to do randomization or anything like that. Now in our initialized particle module, if I set that all, we could change the drop down to say use something random. Great. Well, that isn't available to us. Well, it is available to us, it's just not been coded in this way. So if I wanted to do this, let's say this one, let's edit this one to be using the other method. So if I change this back to direct set, in my lifetime, rather than just using a number here, I've got this drop down arrow. Now this is where the real power of Niagara comes up. It's not just about making a module filling in the values. It'd be nice if it was. Sometimes you can get away with that. But also we can change the inputs to be other dynamic inputs, other things. So in this case, we want to have a random value. So if I type in random, a random range float, I know this is a float because of the color coding, and that's what lifetime set. And now I can do a random value between 5 and 8. Now in terms of the logic, in terms of the code that Niagara will output, this will be exactly the same. If I change that to random, random 5 and 8, or if I use direct set, random range float 5 and 8, 99% sure this will be exactly the same, because it's doing the same thing. It's just using a dynamic input for it rather than using the hard-coded randomness that comes in the engine or comes in the module. Same here, same with all of these things. Everything can just be randomized, can be set. We can use data to drive other data, we can combine things. All of that stuff comes, and it's very powerful, and that's sort of the beauty of Niagara versus something like Cascade, where it was just put numbers into hard-coded boxes. Now what are we doing here? If we go back to our shape location, they have used a random range vector, so a random value between a min and a max, and just set that min and max to 1. Now here, box midpoint, if I change my drop down, I'm going to do a random range vector, and random between 0 and 1. And what that's doing is it's just moving our box. So if we think we have our central point in our emitter, let's do that there. Sometimes our box is up here, sometimes our box is down there, and it's just moving that center point of the box as it spawns our particles. Realistically, I'm not sure that does very much compared to just having a slightly bigger box, but maybe it does. Maybe there's something there that I'm not quite seeing, but for now we're not worrying about what they're doing or how it's doing it. We're just copying the data across to see how it works. This is all the same. Transform, it's all been left as default. Okay, so what have we done in this module? Well, we've added the initialized particle and shape location modules. Note you can multi-select and get a really big list over here. You can then also type in up here and let's say, I don't know, spawn whatever you want, and it will highlight. So it's a very nice intuitive way of searching for things. You can also select the module group section as well, and that will do the same. Give you all of the details for that. But what have we done? We've set some initial randomness, random lifetime, random rotation, etc. And we've set our shape location, so where are our particles coming from. Now there's definitely some errors with this. If I were to isolate the new one, you can see these are popping in, they're completely static, they're not moving. So there's definitely some more data to add, but there's also all of these modules here as well. So in the next video we'll go in and we'll start adding some of the update modules and see how they work. Okay, so we have our particles. They are, or our emitter is looping. We are spawning particles at a rate of 50 particles per second. We are randomizing the initial size and shape and things of our particle, and we're spawning inside a box. Now we want to have a look at making edits to what happens to the particles during their lifetime. So we're now in the particle update stage. So this is going to be happening every frame. And the first thing we want here is a particle state module. Particle state. And what this has is just a single option. It says kill particles when lifetime has expired or elapsed. Basically, you don't have to kill your particles. You can just spawn them and have them there forever. You have to be a bit careful with it because of performance reasons, but we'll cover that maybe later. But that's what this module is doing. It's very simple. It's just saying if our lifetime has elapsed, if the particle lifetime is over its spawned lifetime, then kill it, and that just pops off. And so you can see our particles spawning in, and if we watch them, some of them might start popping out again as well, and so we're getting that end of lifetime. Now this is a little more complicated than it used to be. It's using the wind force and aerodynamic drag, but we'll cover those in detail later on. But this does give us our first sort of inbuilt warning. Now you can see the little red dot saying errors and info, big red triangle here, errors, log. That should give me an error, no? Is it just let me ignore it? Fine. But there's something gone wrong. We can see something's gone wrong. It's giving us information about that. And what is it? Well, if we open up the errors up here, we get a little bit of a description of how it works. But what we want down here, this module has unmet dependencies. This is a very common error to get. What is it saying? Well, the wind force module is applying forces, but the engine or the system doesn't know how to solve those forces. And so we want to add a new dependency module, solve forces and velocity. And if we just click fix, it will do that for us. Now, there are times we don't want to do that, and we can dismiss this and we can just work with it. But in this case, we do. We want to apply this wind force that we've created. If I click fix, it'll create this one here, solve forces and velocity. Now that isn't the only error we have here. It also wants a new dependency module, aerodynamic drag. And if we click fix, we can see we have the same modules here. This also has unmet dependencies, which actually isn't being used here. But we'll cover again that in a bit more detail. Saying align sprite to mesh orientation. If we turn that on, that's doing a thing. Well, we're not diving into what these things are doing at the moment. We're just trying to copy what's there. And so I'm going to go and I'm going to dismiss this issue because it's not actually necessary. Now the little purple, little dot there is just showing this note. If you want to keep the note, that's fine. If you want to dismiss the note, that's also fine as well. So worth reading through all the module notes. Whoever's made the module has given you some information, and we'll do that when we go through the module by module later on. Okay, so what did we just do? Well, we added some wind and we added some drag. So we're trying to replicate the idea of forces, wind blowing things around, and aerodynamic drag, so air resistance, all of that kind of stuff. And as I say, we'll go through these modules much more detail in the module breakdown, but for now we're just going to copy the data across. So wind speed and speed scale, speed of 1, scale of 1, so that's going to slow right down, that's fine. Curl noise direct set 4.6, we can multiple select these if that's more helpful. So scale of 4, frequency of 6, and that looks to be -50, and just copying that across. Obviously we could just Control C, Control V, and that would copy across as well, but we kind of want to go through and see what these modules are doing, at least basically here, before we get into more depth with them later. And this process, this kind of reverse engineering and copying something that already exists, I think is a great way to be learning. This is how I did a lot of learning of Niagara in the first place. If I'm doing something more complicated and I have a good example of it working, this is exactly how I would do a breakdown and learn how that worked. So this isn't a trivial exercise, I don't think. There's a lot to be gained from getting things and just copying across and seeing what the numbers do. Okay, so now we have some movement. We've applied a wind force, not very much, but a little, to create some movement. If we want more, well, we can adjust the scale. That's going to blow things around a lot more. And again, we'll go through these settings and details in the module breakdown later. There's a couple more modules to put in, and a problem we can see. Now, these particles are doing what I would call popping. It's a semi-technical term. Whenever you have a big change in something in a single frame, you have a pop. It's not there, and then pop, it is there. It is there, and then it dies, and pop. There's a big visual kind of, adjustment, a big visual change in a single frame. I would call that popping. Now, some things do pop. You might make an explosion, you might pop things into existence to get that force. But generally, especially slow moving things, it's pretty eye-catching. Things wouldn't just appear and disappear. And so we might want to adjust them. So next module we've got in our template, scale sprite size. And we'll just add that in, scale sprite size. And we'll put that in the same place. Sometimes the order matters, sometimes it doesn't. So for now, we're just going to keep them in the same place, and we'll cover when it does matter later on. And what we have now are particles that are animating. Now this is by default set to a curve, and it's just a uniform curve here. This scale sprite size mode is multiplying by our initial size, which we set here in initialize particle, and we can see over the lifetime of the particle they are scaling up. So they appear very slowly and start at nothing, and then they scale up, and then finally they pop and disappear. Now this is using normalized age. Now this is a very common concept within particle systems. We have a variation in our lifetime. Some of these particles live 5 seconds, some of them live 8 seconds, some of them live 6.3 or whatever, any value between these two. But there is a variation. Some particles live a long time, some particles live less. Now, if we're animating, we can't animate our particles to be at a certain size at a certain time. If I say at 8 seconds, scale down to nothing, what about the ones that only live 5 seconds? It doesn't work. So you have to have a different sort of idea, a different understanding of how you animate. And that's where this idea of normalized age comes in. And so whenever we're dealing with anything normalized, what that means is it's been kind of rescaled and readjusted into a 0 to 1 space. So all particles spawn at 0, all particles die at 1, and all the values, whether it's a long lifetime or a short lifetime, it doesn't matter, it's all scaled so that that's always true. So effectively, it says it here in the tooltip, the age in seconds divided by the lifetime in seconds. So if it's at 5 seconds long and it's going to live 5 seconds, it's at 1. 5 divided by 5 is 1. That's the full lifetime. If it's at 5 seconds but it's going to live 10 seconds, well, now that's at 0.5, right? 5 divided by 10, 0.5. And so that deals with this randomness here. We can do the same with rotation. Rotation normalized angle. Well, I know there's 360 degrees or pi by 2 radians, 2 pi radians, a number of pi radians in a circle, but I don't need to know that. I can just know from 0 to 1 and use the normalized angle. So 0 is not rotated, 1 is full rotation, 0.5 is half a rotation. Much easier to work with that sort of logically in some cases. Okay, so that's why, or that's what this part of the curve is doing. Normalized age, that's what we're reading in. So we're reading the particle's normalized age, and then we're reading that value on our sort of x-axis here. We read up, so at 0.5 we read up here and we get a value of 0.5, and so our particles will be half the size that they spawned at, half the maximum size they spawned at halfway through their lifetime. Hopefully that makes sense. There are some default curves up here, some templates. We can save out other templates, and we can also add these to our curve editor down here. And so you can see here our uniform sprite curve scale, and that's just duplicating the data. So if I'm changing it in one place, it's changing in the other. Okay. Said a lot of words, but it's not actually doing what we want. Well, what do we want? We want to take our particles and we want to scale them up and then scale them down. And if we click on this one, sprite size, for my template, we can see that happens. They scale up, they slowly scale down, and then at the end of their lifetime, they scale down to nothing. Now this is using different tangents. As I said, it's a fully sort of featured curve editor. This is a linear tangent. So if you right click, the shortcuts are the number keys. If I select this one, I can select and adjust the tangents. And there's a lot of power and control in controlling how your animation curves work. If I start here just with a soft fade in and out, they'll sort of fade up and then down again. If I middle click with the mouse, that'll add another point, and we'll just copy what was there before. So this is a point here at, well, I don't like round numbers. Well, I do like round numbers, so I'm just going to put this in myself. 0.1, 1, 0.8, 0.8, something like that. F will frame your graph, and you can turn on and off snap if you wish up here, and you can also just use the templates and save things out as well. So here we're going to fade in, or scale in I should say, then slowly shrink, and then finally scale out, which is what what's doing here as well. There we go. Make them look the same. Cool, so that's dealing with our popping. But that's not the only way we could have dealt with popping. This is dealing with it with scale, so making things scale in and out. We could also fade things or multiply their color. So we're going to use a scale color model as well. So our initial color is set here. Scale color. Again, let's drop it in the right place. Now here, this is just set with values. There's no animation curve here. The default in the scale sprite size module was to use a curve. Well, the default in the scale color module is just to use numbers. But that's not a problem. We have dynamic inputs. We can always change in and add a curve. So in this case, anything we want to animate, we can just use a curve to control, and then we can go in and set our keyframes and do that. So here, scale alpha set float from curve, and it's just fading in and fading out again. So very simple. So scale color. As always with Unreal, you have the reset to defaults, and you can see that's now just a single value. But if we want to, we can always do float from curve, and then we'll just do fade in and out. So that's actually just one of the presets. And if we've done that correctly, what we should find is these two are now basically indistinguishable. And if I just make this one red and this one blue as a quick example, we should see there's very little, or basically no difference between those two systems. Cool. Let me just save that. So quick recap of this video and also the last two. We've come in and we've added some forces and drag to create movement. We've added some scaling both to the size and the color to sort of deal with any popping and give us a bit more of an actual feel. And we've just, well, briefly created one red and one blue. But we've been using dynamic inputs. So places like here, scale color, we want to scale with a curve. We want to scale with an animation. Well, we need to tell it to do that. So we need to put that setting in ourselves. Float from curve. And same sprite size, scale sprite size, that's another curve, and so on and so forth. So as particle systems go, yes, it's a little simple, but dust particles floating in the air is probably something that exists in most video games, or at least the kind of games that have high-level particle systems and stuff, maybe not little stylized things, but it's a very common effect to have. And it gives us a nice kind of introduction to how Niagara works. So that workflow of adding a module, setting the values, changing the inputs if the values or the inputs aren't correct, so that we want to have other inputs such as curves or linking data, that kind of thing, and then slowly building it up. Now it is common with particle systems, you can't really see anything until you've done a first pass. So if we were trying to sort of like art direct this and very specifically put this in a very specific level, let's say the windiness is too low, we want more wind, we can go in and do this, but we kind of need to do a bit of everything before we can see anything. So what do I mean by that? Well, we need to have initialization values, we need to have lifetime, particle size, all of that kind of data. We need to have a spawn location, we need to have some initial forces, we need to have some kind of renderer. And so when we're making our effects, we kind of need to do a first pass, make a load of things, then look at it, work out what's working, what's not, what's too big, what's too small, what's too fast, too green, whatever it is. Then do another pass, and then do another pass, and then do another pass. It's very iterative, it's very tinkery. There's a lot of kind of change a value, have a look, change a value, have a look. Maybe 5's too much, let's try 3, and then have another look. Maybe that's too low, let's try, I don't know, 8. And that kind of workflow. So with the examples that we're doing, obviously we can just take numbers and put them in, but do have a play with those numbers. See, is that too slow? Is that too fast? Now, hopefully the names make sense. Wind speed scale. Okay, well, I can understand what that does. But plug in a number and see what happens, see what changes. Obviously that makes everything move a lot faster because the wind's a lot faster now. And yeah, that kind of approach and workflow works very well. Okay, so as a first particle system, I think we've done pretty well. We've gone through every step by step. We've built this up and we've made ourselves something that matches what was already here. But now hopefully we understand what the different modules do, how a module is only affecting certain parts of a system. This only affects the forces, doesn't affect the size or the scale or the color, anything like that. It only affects the movement. And so things are broken down. And we can see how we can kind of like add and build up these things. So cool. In the next video, we're going to do this all again. So as well as this hanging particulates, little bits moving up in the space, we have this one, mesh burst. There are a few different settings and ways of controlling things when they're meshes and when they're burst particles rather than looping particles. And so I wanted to do a sort of second run through of that same approach, breaking it down one by one. Yeah, and we'll do that in the next video. Okay, right, so same idea as before. We're going to start with a engine template example, in this case the upwards burst mesh. So right click, new Niagara system, from selected emitters, scroll down, right at the bottom here, upward burst mesh, just green plus or double click, and class upwards burst mesh. And then we're going to add an empty emitter, right click, add empty, and copy the modules across, breaking down each one and going through the different settings. Now, in this case, we are dealing with both a mesh renderer and a burst of particles, and that has some sort of small knock-on effects to how we have to build things, how we have to make things. So first thing I'm going to do is I'm going to actually add the mesh renderer here so we can see what's happening. So little plus and mesh renderer, and if I select this one here, it's adding two different meshes, the S arrow and S nomon, and so we'll just click to add two elements. Oh, that was too many, delete, and we'll do S underscore arrow and S underscore arrow. And we'll just give this a name as well. First mesh. There we go. Okay, so obviously not seeing anything right now because we've not told it to create any particles or anything like that. But I just want to get the renderer set up so when we do start seeing things, we will see them. So this has got the arrow index 0, the nomon index 1, so we'll just swap those around. Let's do it this way, arrow, nomon. There we go. And it's overriding the materials as well. So material override enabled, add an element. So we can tell it here to override the materials on the mesh, basically, and it's using the non-alpha material. So if I just set that as well here, sort mode, view distance, and as I say, we'll go through all of these settings later on when we break down the individual modules, but I just want to copy across and get that workflow and get that idea. Okay, so coming down from the top, everything the same here. We need an emitter state, same as before, emitter state. Now we have two options. We can either use the self option, which is referring to this emitter has its own kind of life cycle, or we can use the system-wide one, and the system has a system state and has its lifetime and life cycle. So currently our system is living an infinite amount of time, or is looping an infinite number of times. Each duration of the loop is 5 seconds, but our emitters are bursting, and so they are living self. I'm going to do once fixed 1 second. So the emitter here only lives for 1 second, and then it stops. And you can see here the lifetime. If I make that longer, it should affect this value here, so our loop duration. Now it is slightly cheaper for our emitters to refer to system as opposed to self, but we'll leave this here for now. We can always make changes and edit this later, and again we'll go into more detail when we do the modules. Okay, so before we had a spawn rate. How many particles do we want to have per second? In this case we're doing a spawn burst, and this is set to 80, as we can see here. Now this is an integer, you can see the slightly different color. You can't have 80.5 particles, it doesn't understand that, doesn't work, it's not a thing. Okay, same with our count. We can see here our particles, so the upward burst mesh is spawning 80 particles and then they are dying. Now this one is not dying. Why not? Well, we haven't got a particle state module, so in update we'll add particle state. ST80. I will say all of these kind of like default ones, there is an emitter called empty here. Now we've been using the right click empty emitter. The empty emitter comes, they're both called empty emitters, but the right click add empty emitter here comes without anything. The empty template comes with things like initialized particle, particle state, emitter state already enabled. So don't feel like you're going to have to add all of these things every time and remember them. Actually, it's set up to help you along the way. You can just start with the empty template, and it's got those kind of default modules included. So for learning purposes, I wanted to start with absolutely nothing, but actually when we make things, we'll start with a template that makes sense. So don't think you have to kind of add all these things in here. So okay, well, now our particles are being killed where their lifetime has elapsed. We're not getting any particles. You can see that they're 0. Why is that? Well, we haven't set a lifetime. Our particles don't have a lifetime because it's not been set. So if we do initialize particle, and there we are, we should now get particles for 1 second because that's what our lifetime is. So copying this across, random lifetime between 1.5 and 2.5. That's easy. Random 1.5, 2.5. We're doing a random color, and I'm just going to actually copy that to the clipboard. So if we copy the hex linear, that's the code that refers to this color. It's a nice easy way to copy colors between places. So there we are, and it was minus 0.5 plus 0.5. So starting with this color and then going a hue shift of half a degree in either direction. Now we want to have some movement to these particles. Before we were using wind force in update. Here we're going to set an initial velocity. So add velocity. Now this works similar to the shape module. There's different settings for how we want to use this, and it also comes up with this warning as well. So again, we have dependencies. We need to have a solve forces and velocity in order to actually calculate the values that this force is adding. And again, we'll cover that in a bit more detail later. So we're not adding a linear velocity, that's just moving upwards. That's really boring. Instead, we're going to add a cone velocity. And we can see here we're firing our particles outwards now in a direction. Our cone velocity is between 500 and 1000. I'm going to round that value because that's how I prefer to work. And again, velocity speed here is a single input, so we want to have a random input, random range float. So same idea as before, just bringing in randomness where we need it, changing dynamic inputs when we need them. Cone axis, these are firing upwards, these are firing along the x-axis, and you can see the x-axis down here. So we change that to up. That looks good. Got the direction correct now. And it's using these settings here as well. So distribution along cone axis and speed fall off from cone axis. So again, we'll cover those in a bit more detail when we're looking at the add velocity module. What's that? 875. 875. Lastly, our particles here, they're all, well, they're not aligned with their velocity. That is a thing you can do, and we'll cover later, but they are all not randomizing their initial rotation. If we have a look in here, mesh scale mode, mesh renderer, well, there's no mesh randomness, mesh random rotation. Here we had our sprite rotation. It's a separate module. Initial mesh orientation, so we'll just create that as well, and it's just set to random, so now they're all in a completely random direction. So now we did skip a couple in here. We set random color, we set random lifetime, position is fine, mass, but mesh attributes, if I just highlight just the mesh ones, we want a random scale. So if I go in here, mesh scale. Same as with sprites, we have uniform, so we can scale our meshes uniformly, as in all axes at once, and we can do non-uniform. Oops, where are we? Non-uniform. Obviously with a mesh, it has 3 axes rather than 2, so with a random sprite, it had 2 axes, just horizontal and vertical. Now we can make them really long, really wide, or really wide in the other axis. Whatever we need. So when dealing with meshes, you're often dealing with another axis because you're dealing with a 3-dimensional thing. Looking at what's here, random size between 0.5 and 1. That's easy. Uniform, well, actually random uniform, 1.5 and 1. Now we mentioned before that the sprite scales here, these are in Unreal units, so in centimeters. Well, for meshes, they're multipliers. So a value of 1 will scale the mesh, well, won't scale the mesh, it will be at the scale it was imported. 0.5 will be half the size it was imported. So when dealing with meshes, again, slight difference, you're dealing with scales as multipliers rather than direct settings of Unreal units. Mesh renderer array visibility mode. Okay, well, we'll go through that one here. We added our mesh renderer. We added 2 different meshes, the arrow and the non-mon. If we look, we're only actually getting the arrow. We're not even getting this random mesh. So that's what this setting does here. If we set this to random, we can hook it up to which mesh we want. So the mesh renderer, in this case, we're going to select the mesh renderer. So if you had multiple mesh renderers, you could use it to control different bits. And we're just going to say randomize our mesh, and now we should see that we get it's a bit tricky because the force is so high. Let's make them a bit bigger, will help. And that you can see sometimes we get an arrow and sometimes we get the full non-mon. Cool. As I say, all of this stuff we'll go through at a later date in a bit more depth when we go through the module breakdown. So going a bit quicker on this one, might still split this into 2 videos rather than one really long one. Just a quick recap then. So we were using a mesh, so our mesh renderer, so we're just plugging in meshes instead of plugging in materials. we're using this override option, and we're randomly selecting between these two based on our initialized particle setting. The other option here is to do direct. If I set that to 0, it will do the mesh in index 0, and now they're all arrows. If I set that to 1, now they're all axes or numons. Again, a bit tricky to see, but that's how that works. Go back to random. And so, yeah, big differences when working with meshes. Firstly, our scales are now in multipliers as opposed in direct and real units. If we're dealing with sizes, we're dealing with 3 axes. We have 3 items of data rather than 2. And with a burst, we need our burst to be combined with a set of a life cycle of just once, and that will then just fire and forget. As I say, similar to the timeline resetting here, this will just automatically loop, whereas if I look in the world, it fires once and then it will never fire again until I tell it to refire. So the preview here of what we see of this loop is not what we actually see in the world here. It's looping for convenience. Whether that's convenient or not, I will leave it to you to decide. But yeah, adding initial velocities, etc., and creating this simple particle. Okay, in the next video we will add the update section and animate the size and scale and rotation and stuff as is similar to the template. Okay, right. So we have our particle spawning in a burst. They are using a mesh and the various settings that are required because of that. And let's do some updating in here. So first thing, gravity force. This will use the correct default gravity for Earth, which is minus 9.8 meters per second, and will give us this downward acceleration. So now we get a bit more of a realistic sort of simulation to that. We also have drag. Now before we used aerodynamic drag, that will do some additional calculations for sort of thin objects. It says here like paper or leaves. Drag is just a sort of generic reduction in physics force every frame, and it's using both drag and rotational drag. That's the defaults there, that's fine. Update mesh orientation, drop that in here, wants to be after gravity. This is using rotation rate, that's fine, and we're doing a positive or negative value, and we'll do that here in our rotation. Okay, so the random vector, a random range vector, range vector minus 0.5, 0.5, that was correct. Yeah, so we're getting a little bit of rotation on our meshes. If I change my rotation rate up really high, we can see that that's spinning, and so it's just picking a vector to rotate around and then rotating around with a certain speed. One thing to note, this is using evaluation type here, spawn only. Now the module is in update. Modules in update run every frame. So if this was set to every frame, it's going to randomize that value every frame. And we see we're getting a bit of jittering. If I put rotation rate up faster, it's maybe a bit easier to see. Well, let's do it with a color module instead. And let's do a size, scale mesh size. Now if I did a random range vector. Now if I do a random vector, random size here between 0 and 1, some are big, some are small. That makes sense. If I change this to be every frame, you can see they're sort of flickering and jittering. So anything that's in update happens every frame, every update. But luckily, Epic have added these little options here, evaluation type, spawn only. So when you're dealing with random values in update, it will automatically pick up that you're trying to do something that doesn't really make sense. And so it'll go, okay, well, I want to do this on spawn only, and it'll just randomize it once and then stop. Generally, it's pretty good. It picks up what you want, and so you don't need to worry about it. But that's what this evaluation type means. It wasn't there in the very first parts of Niagara, very first releases, and so you had to create your own parameters in Spawn and then use them in Update, and that workflow still works 100%. But anything you want to do randomness, where you want to do randomness in an Update module, you don't want your randomness set to every frame, unless you do. There's times maybe you do want that, but that's what this evaluation type Spawn only or every frame is covering. Okay, so spawning, rotating, firing up in the air, pretty cool. Currently we're doing the same popping that we were getting with our previous system. So we want to have scale color, for example, and so we're going to scale how things look, and so not using the scale RGB at all, but scaling the alpha down in the second half of its lifetime. Notice this keyframe here is at 0.5. Unfortunately, the graph editor isn't always particularly useful, or isn't always perfect. If we frame it, it will frame the keyframes that exist, but actually it doesn't. It makes it look a lot like it goes from the start of its lifetime down, but actually it doesn't. It's 0 to 1, so just be a little bit careful. Generally, when you're putting your own data in, you'll know where you're putting your data, but when you're copying data, just make sure that you're copying the right things. So how do we do this? Well, I can disable scale color, change my scale alpha to float from curve, and then it's a curve like this, but with this value here at 0.5. So halfway through its lifetime, just start scaling down until at the end of its lifetime it scales to nothing. Oh, that's alpha, not size, apologies. So it's scaling and fading out. And then scale mesh size. Let's do that module as well. So scale mesh size. Now here we have our first sort of nested input. We're scaling our module, or we're scaling our mesh, because that's what we're doing, is mesh rendering. But I don't want to scale individually. I could do vector from curve. If I type in curve, vector from curve, we get the vector curve editor, and I can manually put keyframes in for each one of these. And that would work. Nothing wrong with that. It's just a bit of a convoluted workflow. It's a bit more complicated than it needs to be. So rather than doing a vector from curve, if I reset, what I'm going to do is I'm going to do a conversion. I'm going to do a vector from float. Vector from float. And what that's going to do, a bit like how here we have uniform and non-uniform, well, we've got the same idea, the same approach. Let's put these in the right places. Here we go. I want uniform scaling. I always want my mesh to grow or shrink by the same amount in each axis. And so by using just a single float value, when you convert from float to vector, what it does is it takes the float value and puts it in each channel of the vector. So 1 converts to 111, 3 converts to 333, so on and so forth. So by using a single float, we're able to do uniform scaling of our size of our mesh. So we're affecting our vector from our float. But the whole point of this was to do animation. Well, there's nothing stopping us using a curve to drive our float. So now we've created a sort of nested set of inputs. So the scale factor, that's a vector, could be 157, could be 39, whatever, doesn't matter. But it's 3 items of data. But we don't want 3 items of data, we just want a single item of data because we want uniform scaling. So we can do a float, convert that to a vector. But how do we control our float? Well, we don't just want the whole thing, constant value the whole lifetime. We want a curve over the lifetime, and that's what we're doing here. And so here we can sort of nest our inputs, and there's nothing stopping us adding more and more inputs and nesting and nesting. You might get 5, 6, 7 inputs deep. At some point it starts becoming worthwhile making your own module, and we'll cover those sort of user created modules later on as well. But realistically, there's nothing stopping you work here and just nesting and nesting and nesting and nesting until you get what you need. Cool, so what are we actually doing? Well, we're going to scale up over lifetime and then shrink down right at the end. So let's do that. So let's actually just start with the template. And I'm going to scale up and then slowly scale up more. Now, Doesn't really matter whether these values are normalized or not, but personally, if I'm scaling, I want the maximum to be 1, and then I can change the size to make it bigger in here. Sort of a simplicity point. If my animation curve only ever goes from 0 to 1, and then my size is set in my size module, that makes sense. If my size animation curve goes to 2, well, it doesn't matter, it still works, but now I'm just like doubling the value in here for some reason. But yeah, again, that's not essential. That's just a little style point that I like to keep things segmented and sort of compartmentalized. There's a lot going on, as you can see. This is again quite a simple system, quite a simple emitter, but we're still looking at, I don't know, hundreds of parameters, tens of modules. And so anytime we can simplify things and create kind of like a standard that we always keep to, I think it helps to keep things clearer and simpler. And we aren't quite exactly the same here. Let's maybe curve this up like it has. And we could tweak this for days, but yeah. Cool. So what have we done? Well, we've given it some rotation, we've given it some gravity, some movement, we've animated some properties over its lifetime, both color and size, all similar ideas as the previous system, but this time, because we're working with a mesh, we're working in 3 dimensions, we need to have some adjustments to that. Most interesting of which probably is this idea here, using a single float to drive a vector, basically doing uniform scaling, and we do this kind of thing quite often. And nesting inputs. No reason why we can't use one thing to drive another thing, and so on and so forth. Okay, that's another kind of preview done. If I disable these, they should look exactly the same. I think they do. If you're still a little bit confused about Niagara, there are many more templates. I would say, oops, that wouldn't be in here. We go to the introduction section. There are other templates. Please do try giving them a go. Omnidirectional burst, that's another burst. Fountain, that's another loop. Maybe try those 2 out and do the same process that we've just done. It will help you get a feeling for how Niagara works, what the different modules do, all of that kind of thing. And so in the next section, we're going to really go module by module and break them down and look at all the possibilities. And so it's going to be a little bit more sort of technical in theory. So if you are kind of still struggling a little with Niagara, maybe spend a little bit of time making some more template examples or making your own effect. What we've covered in terms of size and spawn and location is a lot there that you can do some cool things with. So do have a play and get comfortable with the system before we get on to a deep dive into all the different modules and what they do. And then finally the worked examples as well. But before we do that, I did mention user parameters, and we'll add some user parameters to these. So these don't come with user parameters in terms of templates, but we'll add our own, and we'll kind of extend the functionality a little bit, but we'll do that in the next video. Okay, right, user parameters. So let's do it to the hanging particulates, although what we're doing will apply equally to both systems that we've made and all systems that we will make. So we have a series of data that is driving our particle system, and I'm just going to disable that one for now, just use the one that we created. Now we have here a series of small blue dots moving around slowly. Now we could make some variations to this. So we could save our asset, we could make a copy, duplicate, and make larger particles, and maybe we'll have large blue particles that float around, and then we'll make another one where it's even bigger, or maybe they move faster, or all of these kinds of variations. And that works. Nothing wrong with that. That was how Cascade basically had to be used. I think maybe you could do user parameters in Cascade so long ago. Anyway, it's not a very good workflow. That's kind of my point here. We're creating a lot of data, we're creating a lot of duplication. We only want to change one thing, let's say size. But if we change that size, now we need a whole new system. And then now we want to change the color, and that has to be updated in lots of places. And it's a really, really messy thing to do. Instead, what we'd much rather do is to make user parameters. We'd make some data, make some edits to our model that we can then update in the world. Now, if you've done the materials course, you'll have come across instances and also object primitive data, mesh primitive data, which allows us to select the object and set parameters on that. And that's exactly what user parameters are going to do. So if I go into my user parameter module, I'm going to add a new one, and it's going to have a type. So we're going to go into the common, and again, we can just search and type in what we want. But I'm going to make a new float. It gets the user namespace, and I'm going to call this size scale. I'm going to set the default to be 1. Now, it's very important when you're making these to set your defaults. If we don't set our default and we're multiplying by 0, we're not going to see anything until we put it in the world and set the value. Horrible workflow. Make sure you set your defaults. Can't stress this enough. But now we have a multiplier. We have a multiplier value. And what do we want to multiply? Well, we're multiplying our size. Now, we define our size in 2 places here. One in our initial size, as such, and also in our scale sprite size curve. And in the curve module here, there is a scale. So this value here will multiply by the curve, which will multiply by the initial value in here and give us our final size result. So for example, if I wanted to make them 10 times bigger, I could multiply it by 10 in here. I could multiply this value by 10 and also this value by 10. And now my curve is 10 times larger. I don't know if they'll let me do that. No, fine. Oops, divide by 10. Remember, the inputs in Unreal can all be used as a calculator. You can just type math into these things, which is very useful. And we could set our size in here as well. Now, simplest thing to do would be to just update this uniform curve scale. Just drag and drop. And now that user parameter is driving the curve data here, is driving the value there before. And if I change the scale value here up to 5, 10, that's what we had before, you can see it's having that effect. Now what's really powerful about user parameters is if I close my Niagara and I go over to my my actor in the world, I can set that value per actor. Oops, I'm going to copy the component, I want to copy the actor. There we go. And this means we don't need to make lots of instances. We don't need to save out copy and copy and copy of our different particle systems. If there's just a small change, we can just do that with the user parameter. Very, very powerful. It can also be hooked up to code. These can be code driven. So if we're making some kind of magical effect, let's say it's an attack, and as your character levels up, your attack gets stronger. Well, you can just create some parameters and scale those values as you level up. Multiply by 2, now suddenly it's faster or brighter or whatever it is, and that can all be done dynamically within the system using these parameters. Cool. That totally works, no problem with that. Not personally though, my ideal workflow. We're using this size uniform scale curve to do a multiply and multiply by everything, but actually I don't want to change this. I want to change the initial size, and so I'm going to edit in here. It's a bit more complicated, but that's fine. So rather than using the inbuilt here random uniform, I'm just going to set this to uniform. I'm just going to set it to a single value, and now we have access to all of the inputs, dynamic inputs that we'd have before. And what I'm going to do is I'm going to do 2 floats multiplied together. And in the first float here in A, I'm going to do my randomization. And then in my second float B, I'm going to do my user parameter, size, scale, user parameter. So you can click and drag, that's fine, or you can just find it in the list as well. And so what did I have before was 2.5, 3.5, something like that. And now I've set my initial size to be somewhere between these two multiplied by this value here. and that gives us our initial value correct. And then our sprites are our uniform scale curve. This is now available. If we want to make quick edits later on, we can still quickly do that. But we're not overwriting it with the parameter here. We're using the parameter in the right place in the initial spawn. But it doesn't really matter. The end result is basically exactly the same. It's just where you're choosing to control your data. Cool. Let's do this again. Let's do one for, let's say, the wind speed scale. So using parameters, add a new one. And let's do wind direction actually, because it's going to be a vector, just to be a different data type. So I'll make a new vector, wind direction, default. Again, set your defaults, and we'll change that to wind speed here. Speed and direction. So I like to keep wind direction as a normalized direction value, and our wind speed as a scalar multiplier. Here it's been combined together, but actually we don't want to do that. We don't ever want this wind direction to be able to be over 1. So I'm just going to put a normalized vector in here and then normalize our wind direction just to keep that safe, because I want the wind speed to control the amount and I want the direction to only control the direction. And so normalize will make sure that whatever gets plugged in here is always going to get normalized. So yeah, now we can do the same. Let's do wind speed scale. Well, rather than creating the parameter and then applying it, we can also select down and we can do a new user parameter, and that will automatically kind of promote that or create that for us. Now in this case it's taken the name, that's fine, apart from the fact that the way I do my naming doesn't have spaces in it. So I'm just going to go in and rename this, because I like things to be really neat and tidy and consistent. And now I've got wind speed and wind scale. Cool. So different ways to do it. You can create them here and apply them. You can create them and drag and drop. You can create them and then find them in the list, or you can create them as an input. All exactly the same, doesn't matter. It's just different workflows and creating these values. But there is one more thing we can do, and that's what we can do, or we can organize things a bit more. So we can create a hierarchy. And so if we have a lot of user parameters, let's create a new category called wind. We can type, and we can just drag and drop our parameters into it. So now we're going to have no, is that not going there? Okay, fine. Wind, and we'll do, I don't know, size. That should be, there we go. Size. So now we have different kind of headings, allows us to really organize and sort out our parameters. If we're dealing with something really complicated, you might have, I don't know, 15, 20, 50 of these things. It's a really good idea to make groups for them, nest them. The more you can organize your particle, the more your colleagues will help you, be grateful that you've done it, and the more, not just your colleagues, but also you in 6-12 months time, you'll come back and you'll go, what was I doing here? And you'll be like, parameter 1, that doesn't mean anything, name, that doesn't mean anything, yeah, nightmare. Or you can go and go, oh, I've got some wind settings to edit, where's the wind folder? There it is, everything's nicely named, nice and easy. So please do spend some time organizing and arranging things and naming stuff. It really does pay benefits in the future. Okay, quick side rant over about naming things, but now we've created user parameters, we've got our system here, we can go in and we can adjust the wind direction. If I put my wind speed up to something like 50, things blowing across in X. If I change that direction to -1 in X, now things are blowing this way. And we can also make things bigger and whenever we want, and we can make parameters for size and scale and spawn. Absolutely everything that we can derive inside Niagara can be parameterized and then made more useful, like so. Cool. I think that's enough for sort of the introductory sections. As I say, there is a lot to go through here. If you are still feeling confused and not quite sure about Niagara, do try and have a go at making those fountain or omnidirectional burst or just some of those templates. Just really have a play with it. You can't break it, but it is sort of important to have a vague idea or kind of understand that workflow, because we're going to have a deep dive now in the next section, module by module, into what available kind of modules are there. So if I just open up the section, let's do this, module breakdowns. Yeah, we'll save that, why not? So we're going to go module by module or type by type. So emitter properties, spawn modules, location modules, vectors and velocities, forces, sprite renderer, mesh renderer, ribbon renderer, other renderers, ran out of keyboard shortcuts, animation, materials, automatic particle materials. So all of these different things that we can do with particles. We're going to do a deep dive into the different modules, the different settings, how it all works. And if you don't have that basic understanding, I think it will be a bit of a struggle. So make sure you are up to date with it. Yeah. And then finally, we'll do some worked examples as well. So there'll be some, let's open the level for that as well. Some real world examples where we combine everything together. So using the different modules, we've got some snow particles here, using various noises and forces and velocities, some mesh leaves, simple muzzle flash, hopefully that catches on the camera, a little campfire, a close up, and then finally this sort of dissolving effect as well. So so there will be some worked examples to go through, but the next thing in the list is going to be these module breakdowns. So just make sure that you are at least familiar with Niagara, and as I say, the best way to do that, in my opinion, is just sort of start, copy some modules, see what does what, and then we'll go through all the different module types, and we'll do that in the next video.